All right, so then once we get our points plotted on the x-axis, then we have to stand back and look at our picture, or look at our equation, I mean. Our equation, if we multiplied it out all the way, which we are never going to do, but if we did, it would be x times x times x. That would be an x cubed equation. Would you agree with me? You have a BFF that's an x cubed. Now this is not going to look exactly the same, but it's going to have the same kind of idea. Isn't your x cubed that picture? Anytime you graph an x cubed, it's going to start down here and eventually end up here. That's how x cubes act. So, I don't know, I'm just going to draw in down here. This thing starts down here. X cubes start down there. When it hits that point, excuse me, it passes right through, comes up a ways. I don't know how far, I don't care, that's a calculus problem. Right now, I know it goes up. But it has to turn around and come back down because it has to connect to the next point. All the dots that you put on the number line are going to be connected. You're not going to skip it. So when it hits here, it's going to pass right through, and guess what it's going to do? It's going to come down a ways, and then turn around and go back up. And there is a picture of that polynomial. Easy. Oh my goodness.
Is this what you're saying?
Fun.
Yeah.
Yeah. All right, let's look at the next one. Okay, so you're going to start by putting dots on the x-axis. We call them zeros or x-intercepts. Courtney? I don't know that I have another one. Just write down, my pile's all messed up from when we sorted candy the other night, so I can look for one later. I don't know. It's in Schoology. You can print another one from Schoology. These are the same notes we've been using, so I know you have it because these aren't new notes. These are the same packet we've had for a while. All right, so here we go. Where are the dots going to go, guys, on my x-axis? Where are my zeros going to go? At -4, and I labeled that point at -4, +2, and -3. Now, like the last one, is this an x cubed? Jada. This is an x cubed if we multiplied it out, right? So it's going to behave just like your x cubed BFF. So it's going to start down here. Now, when it gets to this point, it's going to go through, but it has to turn around and come back down. And then it's going to go through, but it has to turn around and come back up.
Wait, this one, how do you know when to go up, down, and all that?
Well, x cubes always start down here.
How do you know? Oh, okay.
And then you just keep going, connect the dots and keep going. Now, the next one has a little bit of a kink in it. A kink. What is different about this next one? There's a squared factor. Okay, so let's talk about how that changes things. Well, first of all, there's only 2 parentheses. So there's only going to be 2 dots. I'm going to have a dot at -1 and a dot at 3. All right, the dots come from the parentheses. If you only have 2 parentheses, you're only going to have 2 dots. Now, is this still going to be an x cubed if I were to multiply it all out? There's still 3 x's, aren't there? one here, or I mean, two here and one here. Okay, so it's still going to start down here. Now, that dot right there came from this parentheses. Would you agree with me? And that parentheses is squared. So guess what happens? You don't pass through, you bounce off. And you're going to remember that because doesn't that kind of look like a parabola? And aren't parabolas squares? So when you have a squared factor, it's not going to go through, it's going to bounce off. Now, of course, it has to turn around and connect to this one, right? And that one goes straight through because it does not have a square. And if they don't have a squared, they go straight through. If they do have a squared, they bounce off. Oh my lordy, look at the next one. Okay, now, we have two parentheses. So that means we're going to have two dots. Okay. All right, so let's talk about that. First of all, two dots, right? Everybody good with two dots? Now, Jada has already noticed that this is not an x cubed. This is an x to the fourth. Now, we don't have a BFF that's an x to the fourth, but we do have a BFF that's x squared. And in polynomial land, even powers all act the same. So x to the fourth, x to the sixth, x to the second, they all act the same. So your cube that we were doing before, your cube started down here and ended up here. That's the way odd powers behave, like x to the third. Even powers, on the other hand, behave like this. They start up and also end up. So since this problem is an x to the fourth, it's going to start up here. You have to remember that odd powers start down and end up. This is what odds look like. Evens start up and end up. You got to remember that. So I look at my problem, I see I'm going to have x to the fourth, so I know I'm going to start up. Now when I hit this dot, I have two choices. I can either go through it, or I can bounce off of it. Well, that dot came from this factor. -3 came from here. That's squared, which means I'm going to bounce off. At some point, I have to turn around and come back down and connect to this one. And now I have to decide, what am I going to do? Am I going to go through it? Am I going to bounce off of it? Well, it came from that factor, squared, so I'm going to bounce back off. So we got a W type shape for that curve. Oh my goodness, look at the next one. I tell you what, when you go home tonight and your mom and dad say, what did you learn in school today? Whip this out. They'll be impressed. They will be impressed. This is a huge problem and you're getting ready to sketch it. And it's only going to take you a little bit of time. What's the first thing we do? You put the dots on the x-axis. So -1, 0, 2, 0, yep. Perfect. Now, the second thing we do is easy to overlook, but you can't. You got to stop yourself. how many x's total do I have? 5. Okay, 5 is odd. Odd is like x cubed, which means it's going to start down and end up, right? So we're going to start down here, and we're going to come up and grab that -5. Now you have a choice to make. Do you want to just zip right through it, or do you want to bounce off of it? Zip right through it. And we're zipping right through it because there's no exponent on that. So we're zipping right through the -5, turning around and coming down to the -1. Remember, they have to be connected. Now when I hit the -1, I have that choice to make. So my eyeballs zero in on this right here. This is where the -1 came from. It's squared. So that means I'm going to bounce off, come back and grab this one, and bounce back off of that one because that's a square. Remember, odds should always start down here and end up here, and yours did. It's got that waviness in the middle of it, but it starts and ends the way it's supposed to. Oh, I love this. Isn't this fun? All right, F. Now, F has another little wrinkle. What do you notice different about F? It's got a Q. Now, I'm going to put my 2 dots on my number line. Katie, you all right? Huh? Okay. Put my 2 dots on the number line. Remember, 2 parentheses means 2 dots. But how many x's do I have altogether? 4. Now 4 is even. Even acts like a parabola, x squared, so it's up, up. So this is going to start up here because it's x to the 4th, and evens are up, up. Now, when I hit that point, it came from here. Aren't I just going to go right through? And I got to turn around and come back up, right? Now, here's where things get a little bit tricky. That factor, that right here, that's a cube factor. So remember when you draw x cubed, remember how it kind of squiggles like that? When you draw this, you're going to kind of squiggle it through.
Wait, what? Just because it's cubed?
Exactly. An x cubed factor squiggles. So basically, kids, there are 3 ways you handle. When you get to a point on the x-axis, you either zip right through, you just zip right through, you bounce off, or you squiggle. You zip right through when there's no power. You bounce off when the power is 2, and you squiggle when the power is 3. Okay, so you physically see that squiggly right there. All right, would you try G? See if you can sketch G.
What do we do with the -2?
Oh,
Good question.
interesting.
So you know what they should do.
Let's talk about this.
Yeah.
Let's think about, let's think about one of our basic shapes, you know, those weird shapes that we had. And if this was f of x, tell me what putting a -2 in front of it did. What did putting the negative do? The negative turned it upside down. And what did the 2 do? Make it It didn't move it up 2, it stretched it, made it twice as tall, right? So, Jada, in terms of graphing your polynomials, the negative is important because it's going to turn the picture upside down. But the 2 is just going to stretch it. And since I'm not really plotting any up and down points, I mean, I don't know how skinny or fat it is, the 2 I'm going to ignore for the time being, but the negative is important. You certainly do not plot the 2 because it doesn't have an X. You only plot the things with X's. So you're going to plot these 3 points. Those are the only 3 points you're plotting. William, I need you to pay attention, sweetheart. I don't understand why you're not fascinated by this, but I need you to pay attention to it. Now, gang, if you were going to multiply this all out, how many X's would there be?
4.
4. That's even. Evens are up. But wait a minute, there's a negative in front of it. So instead of being up, it's turned upside down, and now it's down. It's like a parabola. When they open up, it's up. But when you turn it upside down, it's down. So you're going to start down here because of the negative right here. This turns it upside down. So instead of being like a parabola up, it's going to be like a parabola down. Now, that came from here. So I'm just going to zip right through. That one came from here. So I'm just going to zip right through. That one came from here. So I'll bounce off. So again, the 2 here, this 2, would make this valley go down farther and this hill go up farther. But since I don't know how high they were to start with, I can't really change it. So I'm ignoring the actual numerical value, but I'm paying attention to the negative. Okay? All right, now that I did that one. Try H. Can you do H by yourself? Yeah? Love it. Go ahead, do H. Did everybody vote today, either in real life or in period B?
What did you say?
I said, did you all vote either in real life, like if you're 18, did you vote, or did you do Mrs. Terwilliger's thing and vote during period B?
I voted because I'm grown. Why are you looking at me like that? Are you mad at me?
Did you vote, Ms. Ford?
Yes, I voted a week ago,
Did you vote? Oh, no.
That is not good.
because I didn't want to miss school. So I voted on Mission Monday afternoon.
I don't want to vote because I don't want to bother you.
All right, here we go, guys. How many X's do we have if we multiply it all out?
What?
How many? 5. 5 is odd. Odd starts down and ends up. But there's a negative out in front, which means it's going to start up and come down. Yes.
But X plus 2 is 2 not squared.
Oh.
Yeah, that's all I was
Oh, thank you, Catherine. Well, that changes everything I just said then. Because now it's not x to the 5th, it would be x to the 6th, which is even. Should be up, up, but because of the negative, it's going to be down, down. So I'm starting down here. Now when I hit that point, I have to look up at my problem. Ooh, that's the cube one. So I'm going to redo my picture here, since that's the cube one, so that I can see my squiggling.
So it doesn't matter where the squiggle like is.
The squiggle should be on that point. So Gabe, think of it like back when you were doing your BFFs and you graphed x cubed. Remember how it's squiggled right there through the origin? Make that same thing, only go through the point that the dot is at. All right, so then it comes up and turns and comes back down. What does it do when it hits this point? Right, Dad says it goes right through. So it goes right through. Turns around and comes up to this one.
Bounces off.
And at that one, it bounces off. So remember how you said it was going to be down, down? That's exactly what happened. Right? You're amazing. Good job. Now, let's look at the next problem. Because this is backwards. Now you have the picture, and you have to build the equation. Now, I think you know how to do this. Look at the picture. What might be the first thing that you do?
Points.
Well, you know the points. You know you have a point at -2, which means you'll have a factor of x plus 2. Doesn't that make sense to you?
Yeah, x plus 2, x minus 2.
Wait a minute. I'm on problem 2a, and my parentheses come from the x-axis only. So I have x plus 2, x minus 1, x minus 3. So that's step 1. So that's great point, Jada. Your parentheses come from the dots on the x-axis. I don't care about the rest of the dots in the picture. The parentheses come from the dots on the x-axis. Okay? Now look carefully at your picture. Do you think any of those parentheses are squared?
No.
Oh, wait, yes. One of them squared.
X minus 1.
X minus 1 has to be squared. How do we know x minus 1 has to be squared?
Bounces.
Look at the picture. Doesn't it make a parabola there? Doesn't it bounce off?
Yeah.
When it bounces off, it's squared. Okay? Now, you are all done except for one thing. You know how this problem had a -1/3 out in front? And the last one had a -2 out in front? This thing has a number out in front. We just don't know what it is. But you just figured it out on the quiz you took. How did you figure out that missing number?
You gotta put it on.
You gotta put, and not just any point, Gabe, plug in the one you haven't used yet, which is that random 0, 2 up there. You plug in the extra point. So you're gonna plug in the point 0, 2, x is 0, y is 2. So here we go. 2 equals n. 0 plus 2, 0 minus 1 squared, 0 minus 3. So I plug in 2 for the y, and then 0 for all of the x's. So I have 2. What's this equal? 1, negative 3. So 2 equals, what is all that times each other? Negative 6n? So n, oh, negative 6n. So n equals negative 1/3? I know, there's not a lot of space. It's a lot of work. Isaac?
And then we go back and plug in.
You caught me real fast. That was,
Yeah,
I was on
no,
the screen.
no. You're an addict. And the next time I have to say something to you, I'm taking it.
Okay.
All right? So if you do not want me to take your phone, don't get it out in class anymore. All right. Now, here's the thing. When you write your answer has to be the equation. So y equals negative 1/3, x plus 2, x minus 1 squared, x minus 3. That is your equation. So when you get n equals negative 1/3, and I know that's a lot of work, you did a lot of stuff, that's not the answer. The answer is the equation with the negative 1/3 out in front of it. All right, let's try the next one. Come on, you guys gotta pay attention. Hate to think what it'll be like when we have a boring day. This is an exciting day. All right, here we go.
I think you should have every day.
Now I'm looking at problem B. I'm looking at my picture. And how many dots on the x-axis are there? 3. So there will be 3 parentheses. What will be the 3 parentheses? X plus 4 plus 2 minus 3. Those are the ones on the x-axis. Okay? Now, look at them carefully. Look at those 3 dots. Are they all just passing through, or are any of them bouncing off? They're all passing through, which means that none of these will have squares on them. So you're done, except you gotta figure out what that number is. What point, look at your picture carefully, what point are you gonna use to find that n value? 0, negative 3. You use the one that's not on the x-axis, so you're going to use 0, negative 3. All right, so here we go. Negative 3 goes in for y, and 0 goes in for all of the x's. So negative 3 equals n times, here we go, 4, 2, negative 3. What's 4 times 2 times negative 3? Negative 24. So when I divide 1/8, because I'm dividing by negative 24. So what do you circle? Not that. Y equals 1/8, x plus 4, x plus 2, x minus 3. All right? Huh? No. Got a lot more to do, Roman.
We only got 5 minutes left.
no, we don't.
Panic order.
All right, here we go. Let's look at problem C. Tell me where the dots are. How many dots, first of all, on the x-axis? How many dots in problem C? On the x-axis, how many dots?
Three.
Ooh, there's three. There's three.
Uh,
There's one at -2. There's one at 0.
There's two at zero.
Oh, okay, well, yeah, we're gonna have a bounce there, you're right. And there's one at 3. So this is step 1. Kids, when the dot is at the origin, I write plain x, but if you wanna write x minus 0, you can. That's how you handle the dot at the origin. It is an x value. It just happens to be 0. Okay, so if the dot's at the origin, we either put plain x or we put x minus 0. Now, Vincent has already indicated that this needs to be squared. That needs to be squared. Because if you look at your picture, aren't you bouncing there at the origin? Are you bouncing anywhere else? Yes. Look at your picture. Aren't you bouncing at -2?
Yeah.
Oh, yeah. You're bouncing at -2, so that factor is also squared. You are not bouncing at 3, so that one's fine. Okay, so step 1, build the parentheses. Step 2, put on powers if you need them. Step 3, figure out that number. Okay?
Why is there an x squared by itself then? I'm so confused.
That's the factor at the 0. So you can write x minus 0 squared if you want, but x minus 0 is the same as x.
So, alright.
So I just write plain x anytime it's at the origin. All right, what's my point in this problem? My random point,
2,
2, 2.
why?
William, look at the picture. I don't know how to answer that question. Look at the picture. What is the random point that's labeled there? See it? 2, 2. That's the only other point we have, right? So now, x is 2 and y is 2. Don't get bogged down in the arithmetic. You can do this. 2 squared is 4. Now be careful here. 2 plus 2 is 4. Squared is 16. And -1. So now we're going to multiply all those together. So that will be -64n. And then I will divide by -64. So -1/32.
Don't you have to add them up again?
Do I have to what now?
So it's 64 and
I multiply, this is a multiply problem, so I multiply these 3 together.
yeah, how about
These are factors, so it's always going to be a multiply. And then I'll plug that back in. So y equals -1/32, x squared, x plus 2 squared, x minus 3. or more. Okay, now D did not draw a picture. But D told you, if you wanted to draw a picture, that the zeros are at -1, 2, and 4. You do not have to draw the picture. But zeros are the points on the x-axis. So from that, you should be able to tell me, what are my factors? X plus 1, minus 2, and minus 4. Now, without the picture, can I tell if anything's bouncing or not? So I'm just going to assume no bouncing, because there's no way for me to know without the picture. However, I can find that point, or that number, because what else did they tell me? It contains the point 110. So 10 is my y, and 1 is my x. So without the picture, I have no idea if anything is squared or not. But I do know I contain that point, so I can figure out my coefficient. So 10 equals n times 2, -1, -3. What is that all times each other? 6? So 10 equals 6n. So what does n equal? 5/3. 10 over 6, or 5/3. Don't forget to write the answer, which is y equals 5/3, x plus 1, x minus 2, x minus 4. All right, I need everybody to perk up. We're going to do one more problem. I need everybody to look alive. One more problem, and then we'll be done. Now, look at number 3. This is where the rubber meets the road here. Your job is to sketch this function. Now, we did a whole bunch of those a little bit ago, and it was easy. Because what did we have then that we don't have now? We don't have the parentheses, right? And what did we need the parentheses for? They told us where to put the dots, right? So we're going to have to factor this thing in order to get the parentheses. We'll have to factor that. We'll look at it carefully. Anyone have an idea how we might factor it? What? Grouping, yep. We can factor it by grouping. So if we take the first 2 terms, we can take out an x squared. So we've already talked about this year. From the first 2 terms, pull out an x squared. From the last 2 terms, this one's a little bit tricky. There really isn't anything to take out, so I'm taking out the -1. I'm pulling out the -1. When there's nothing else to take out a 1 or a -1, depending on what that sign is. Now, our parentheses match. And I've got an x squared minus 1 left over.
So when you take off that negative, it changes that sign?
Changes all of them. Yep. So this becomes positive and this becomes negative. So there's my common factor. And then here's the leftover. And what about x squared minus 1? Oh, guys, how does that factor? X minus 1, x plus 1. You're in trouble if you can't remember that. Because that's going to pop up in a lot of problems. Okay, now it's factored. How many dots are we going to have? 3. Where are they going to be?
4 and 1 and negative 1.
4, 1, and negative 1. 4, 1, negative 1. I'm going to draw it. It's x cubed, right? Where do x cubes start? Down. So x cubed starts down here. Are any of these going to be bouncers?
Nope.
Nope. So I just pass through, connect, pass through, connect. Done. That's all there is to it.